These are your questions related to vehicle dynamics applied to race cars, and now it's time we tackle each of them. Hello everyone, this is Bruno. You sent us many questions related to vehicle dynamics applied to race cars. Now we're gonna go through each of them, and it's time we discuss the answers together. So let's go to our first question. Why stiffer springs do not decrease total lateral load transfer? A lot of people think that if you increase the stiffness of your vehicle and it's rolling less, it will transfer less load. This is really not the case. The total load transfer is only a function of the CG height, the mass of the car, the lateral acceleration, and also the track width. These are the four parameters defining the lateral load transfer. When you change springs, yes, you can make the car roll less. You can make the car transfer this load faster. However, the total load transfer will be the same. When you change the stiffness differently between front and rear axle, what you are really changing is the load transfer distribution. So let's say that you have a given amount of total load transfer defined by these four parameters. What you are changing is just the distribution of how much of that load you transfer on the front axle versus how much you are changing on the rear axle. Meaning that if you increase the load transfer on the front axle by increasing its roll stiffness, it will transfer more load on that axle, and as a consequence, it will also transfer less load on the rear axle, so that the total load transfer remains the same. How to read vehicle behavior from the steering wheel angle profile. It is very important that we know how to look at the steering angle profile from the acquired data and read what car balance our car has. What we'll typically see for a neutral car is a steering profile that is smooth. We don't see a lot of oscillation typically, and we don't see big corrections in any of the phases of the corner. This typically indicates a neutral car. For an understeering car, a typical steering profile would be a very peaky one. So we don't see the driver increasing the steering wheel angle and then decreasing it in a smooth way. We see it going higher and higher at the apex before it going down. Typically it indicates an understeering car. The driver is showing this peaky steering profile because it's trying to find more grip on the front axle since it's lacking. For the oversteering situation, not only we would see a lower steering value, but we would see also many corrections. That could be at corner entry, indicating oversteer at the entry, at the apex, or at the exit, indicating oversteering different phases of the corner. Another thing that we should be looking when analyzing steering profiles is the oscillation, which we say that the driver could be more aggressive with the steering wheel angle and apply more corrections or less. This could be coming from different sources. Some drivers will naturally try to find the limit by moving more the steering wheel angle. Some cars are moving more and the driver needs to apply many corrections, or simply your car does not have enough stability and the driver needs to oscillate a lot to keep the car under control. So it's important that you discuss with your driver to understand the cause of that aggression with the steering wheel. Another thing we have to keep in mind is that even though we are looking at the steering profile to read the car balance, it does not tell us the cause of that understeer. It could be because of the car setup, it could be because of the conditions of the track, but many times it's also coming from the driving style of your driver. So how he applies the brakes and the throttle will also determine the vehicle balance. So it's important that you analyze other parameters. We have two videos in our performance engineering series explaining how to read steering, throttle, and brake profiles, and also how steering, brake, and throttle will influence car balance. You can find a link to these videos in the video description. Why does adding ballast to the front of the car make it more understeer? So basically the question is asking, when you change the weight distribution of the car, let's say that we move it forward, why does it induces more understeer? Well, it all comes down to vertical load sensitivity. That states that as you increase the load on the tire is less efficient in generating force. Yes, it does generate more force because it has higher vertical load, it is just less efficient. Meaning that if you add vertical load on the front axle and you shift this weight to the front, you can generate more lateral force. However, this added lateral force is not enough to compensate for the added weight that that axle has to carry. So, in simple terms, you have more weight to carry, but you cannot generate enough lateral force to carry that extra weight. Since the front axle cannot carry that extra weight as well as before, the car will understeer. The same is valid for oversteer when you shift your weight rearwards. So you can see that changing ballast or changing the weight distribution of the car could be a powerful tool in adjusting car balance. Why do you have peak grip when Mx equals 0? When the tire is generating lateral forces, it has some sort of deflection. It has lateral deflection, but it also has torsional deflection. So when the tire is cornering, typically we shift the vertical load to the outside shoulder because of this torsional deflection. Because of that, the vertical force on the tire is not equally distributed throughout the contact patch. If the tire does not have a good distribution of the vertical load, it is not as efficient. So what we could do to overcome that is to add camber, and the camber will shift the vertical load from the outside shoulder to the inside shoulder. If we find the ideal camber, this vertical load will be exactly in the middle of the tire, indicating a better distribution of the vertical load on the contact patch. This vertical load being on the center of the tire will also give you Mx0. So this is why we could say that Mx0 could be providing higher grip, or at least a better distribution of vertical forces. But please keep in mind that this is just an approximation. It's a simple way of analyzing a complex problem. There is a lot more going on in the contact patch and even where you measure your Mx. Since you have lateral deflection, you could have a shift in your Mx due to that. How to evaluate damper setting influence on vehicle grip and stability. So basically here is, if we make a damper change, how can we analyze the influence that it had on grip and stability? In the same way as many other parameters on the car, it's not as straightforward to see or quantify the influence of a damper change. However, it is possible. First things first, even before we look at the data, we speak with the driver, we need to make sure that we're comparing apples with apples. So for example, if we perform 2 runs, one with a given damper setting and the other one where we made a change. If you are using different tires or if the track is at different conditions, if these are different sessions, different drivers, or you had a lot of wear between these 2 runs, it is not possible for you to quantify the changes coming specifically from the damper. So try to be a scientist here and try to make very repeatable experiments before you can analyze the data. After that, a very good way for you to quantify the influence of damper on vehicle grip and stability is speaking with your driver. Depending on how you change the damper characteristics, and we discussed this in another question, you will change the transient load transfer distribution of your car. So you could be increasing the vehicle's response or actually decreasing it if you're getting too much rotation. And the driver will be a very good source of information for that type of behavior. Besides that, you could be working with KPIs, so key performance indicators, using the data to quantify the changes. There, you could be using a few different KPIs. One of them, or the first one I'm always looking at, is the damper speed histogram. Do I see enough change on the damper speed histogram confirming that my change was big enough to change something on the car? And this is again discussed in another question of this Q&A video. If so, if the change is big enough, then what other KPIs can I be looking at? Can I look at maybe vehicle behavior or car balance at corner entry? Because we know that the damper is only influencing the entry and the exit, but not as much the apex. Are there other KPIs in terms of stability that I can be using? So it all depends on the metrics that you are currently using to characterize vehicle behavior or balance in the transient phase. One more thing to keep in mind is that there are a few parameters or considerations from the damping adjustment that neither the driver nor the data will be able to clearly communicate to you. Sometimes you make a change that decreases the vertical load variation, which typically increases grip, but sometimes it's minor. And the variations between one run and the other are higher than this change. So the driver is not able to feel that and the data is not able to at least clearly show you that. But this sometimes you will have to trust your simulations or calculations, especially if you validated them. So try to use, for example, post-rig simulation or post-rig testing in order to minimize the load variation, even though those characteristics could be hard to quantify at the track. What is the best way to use the damping speed histogram to optimize the vehicle's on-track performance? Well, the damping speed histogram characterizes how much time you spend in each region of speed of the damper. So it tells you, are you spending a lot of time at low speed movements, or at high speed movements of the damper. So it cannot tell you directly how much damping you should be running. It cannot tell you should be running more or less to optimize vehicle performance. However, it is a very powerful tool to quantify damper changes. So whenever you make a damper change, you can see how much you shifted of the time you spend in high speed movement to low speed, meaning that you increase damping, or the opposite, how much time you shifted from low speed to the high speed movement, meaning that you decrease the damping levels of the car. Not only that, it helps you to quantify how much bump or rebound bias you have. If you're spending more time in the bump region, you have a higher bump bias, while the opposite is true if you're spending more time in the rebound region. So whenever you make damper changes, or whenever I make damper changes, I'm looking at the damper speed histogram to quantify two main metrics: damping levels, which is a comparison between low and high speed movement, and also damping bias, which is a comparison of how much time I spend in bump versus rebound. It helps you to analyze not only damper changes, but it helps you understand if the damper changes you are making are significant enough. It helps you to compare different cars, for example. And a last point is that it helps you identify issues with the dampers. So whenever you see your damper speed histogram KPIs shifting, it is a clear indication of a damper or damper sensor issue. Changing the ride height of the car can change the balance. Is this due to the weight distribution? No, it is not. When you change ride heights on a race car, typically you are operating within a window of 10 millimeters. This will not shift the weight transfer, at least not in a significant way. If you are playing with just a couple of millimeters, this is not enough for you to shift the CG position forward or rearward, meaning that you can do whatever ride height adjustments with the car, the shift in the weight distribution that you see on the scales will be really, really minor. When you change the ride heights, you are changing the vehicle balance because of other parameters. The main one is aerodynamics. You are shifting your aero balance and how much downforce you can generate on the front axle and on the rear axle. And at a smaller contribution, you are changing slightly your kinematics. So you are changing slightly the roll center, the bump steer, or the camber variation. So these were the answers to your vehicle dynamics questions applied to race cars. If you'd like to submit more questions like these, you can send them to our Instagram profile. If you're interested in this type of content, you would like our seminars. We have a seminar fully dedicated to applied vehicle dynamics, where we're discussing these questions and a whole lot more throughout many days. And we have also our performance engineering seminar, where we tackle how to optimize the car performance based on data. Besides that, OptimumG offers the following services: performance engineering, where you could have one of our performance engineers at the track with you; vehicle dynamics consulting, where we'll help you with vehicle dynamics and tire development; and also simulation software in the areas of kinematics, dynamics, and tires. Thank you for watching the video, and I'll be waiting for your next questions.